The post-lunch session, the first lecture will be delivered by Professor BISWAJIT SARKAR, and I request Sir to introduce Professor BISWAJIT SARKAR.
Professor BISWAJIT SARKAR is currently serving as a professor in Department of Industrial Engineering at Ucheon University, South Korea. He has been honored with very best category Outstanding Professor Achievement Award for 2 consecutive years, 2023 and 2024, for his exceptional research contribution at Ucheon University. In 2021, he was also conferred the prestigious Alchun Endowment uh,
Endowed
Endowment
Prof.
Endowment Professorship
Basically, it's a distinguished person.
अच्छा, by the same department. He pursued postdoctoral research at Pusan National University, South Korea during 2012 to 2013. Under his mentorship, 30 PhD and 6 master students have successfully completed their PhD degrees. Professor Sarkar has also outstanding research record with 394 publications in very reputed international journals and 4 authored books. He is the editor-in-chief of Green Manufacturing and Frontier in Sustainability, Sustainable Supply Chain Management. He also served as associate editor of Humanities and Social Sciences Communications and European Journal of Industrial Engineering, and holds editorial role in numerous Scopus and SCI index journals, including Energies, Engineering Optimization, and Journal of Industrial and Productive Engineering. He has received several international recognition. Some of them are Bronze Medal for Capstone Achievement, N1 University 2016, Bharat Bikash Award for Young Scientist, India 2016, International Award from the Korean Institute of Industrial Engineering 2017, N1 University Academic Award 2017 and 2018, GKF Academic Eminence International Award, Global Knowledge Foundation, USA. His research papers were selected as best paper at international conference in 2014, 2023, 2024, and 2025, held in South Korea, India, and Taiwan. He has actively presented and chaired sessions at international conferences and is engaged in consultancy with an India-based company. Professor Sarkar ranks among the top 2% scientists globally in operational research as per the Standard University study from 2020 to 2024. With this rich academic achievement of Professor Sarkar, we are very proud that Professor Sarkar is with us and agreed to deliver a lecture among the gathering. So, Professor Sarkar, you can start your valuable lecture.
So, can I start, sir? Thank you, sir. So, let me share the screen and let me explain about that. What exactly the situations that say so many things, but let me explain. And sir, do not please do not go outside. The one say below is used. So, is it visible?
Yes, yes. Please.
Why from my side it is not so visible? Okay. And it is the full screen mode.
No, not full screen.
So then, should I cancel and go for Windows? Not for Windows. Let me cancel it. Document. Go for full screen. You can cancel. Oh, but if I put the entire screen, it is not coming. Which one I should do that? Full screen or window?
Anyone you can do. I think both will
No,
work.
but no. But if I go for the window and share, then sharing is done, but it is not coming the full screen.
Okay, so better you share the window.
And if I go for stop sharing, wait a minute. If I go for entire screen, then wait, I guess it will do. Hold a minute, sir. Now, can you see?
Yes, yes, it's fine now.
And full, it is full screen now.
Yes,
Excellent, excellent.
Okay. Thank you, sir. Thank you for inviting me for this um, presentation in front of this gathering. But frankly speaking, I do respect Professor Madhumangal Pal. The main concern in that was that when I joined Vidyasagar University, he was the head of the department. So, with a good relation I have ever with Professor Madhumangal Pal, and with due respect, even though I said that in some conference in some island from here, the internet is the issue, everything is the issue. I have really doubt that can I present or not. But as sir said, so I cannot say that okay, even in this situation I can present or not. So that's why uh, I have something extra good relation with faculty, and this relation started since my joining to Vidyasagar University in 2010 and till now continues. Even though I said to sir several times that please come and visit to Korea, but it was never happened. Hope sir will visit sometime in Korea. And now let me start for my presentation. So I have one question more. Sir, should I go through the Bengali mode or go
No,
through
no,
the
no. Uh,
just spoken English?
Most of the participants from your South India,
Okay, then go
Tamil
for
Nadu, Kerala. Uh,
okay, then go for as the formal presentation.
uh,
Okay, then let me explain my content. That first, the title of the presentation is that if we think about the reworking, that means do you think reworking is really needed? If needed, is the time duration of the reworking is the fixed or is it uncertain? That means first concept is the reworking is the covering part of the remanufacturing or in the main concern regarding the production process. So if we consider the some production process, do we think so that we need the reworking? And if we need really the reworking, when we should do it? Now, let me explain something regarding, suppose this is the pen, and let me explain something. The um, pen, if you see that uh, there are like two colors, and these two color of the two parts of the body of the pen will be produced by two separate machines, and then go for a assembling, and then finally we got the pen. Suppose there are three parts of the body, so then the three parts will be produced by the three different um, machines, and then going for assembling, and then we are getting the final pen. But the concern is that any part of the machine or any specific machine, machine 1, machine 2 or machine 3, if it is making any trouble, then the problem will start that remanufacturing or reworking has to be considered to recover this part. So whenever we are facing this type of trouble, so as this is a multi-stage process, so do we carry the reworking stuff, the reworking product thing, or should we do within the same stage? So that is the main concern. So let me explain through the PPT file. This I am keeping. That is my all this matter regarding my introduction to my presentation. Oh God. So this is the process. So number one, that Introduction part, I will explain about the background, what's the concept that I just started to explain, and what is the objective, and then what's the framework is that, and then we are considering three models, and this research basically I have done with uh, one of my master students finally, but before that I started by myself, then with Prof. and then the third model is with one graduate student, means master student. He completed his master's by publishing six papers, and the last paper is with me. So these were the three different models are there, and finally we'll go for the conclusion. So that is the sequential task. Number one, that if we are going for the industry 1.0, then we are considering the traditional production system, and then go for the industry 2.0, then we are considering CIPS, that is the computer integrated production system, and then go for industry 3.0, then it's the automated and covered by AI, that is industry 3.0. So it's a part of IPS, intelligent production system. And now then the final one, before considering the industry 5.0, so then it is industry 4.0, that is the SPS, generally for the covering by the smart production system, and it is covering with the intelligent manufacturing, artificial intelligence, and with the flexibility in the production system also, with the cloud computing. So these are the combination things that are coming from the smart production system. So how they are connected? So then let me explain a little bit that suppose we have a demand of 50 products. If the demand is 50 products, so then this information from the system, it will move to cloud immediately. And then if the uh, in the cloud this information reach, then using the artificial intelligence force, it will be immediately calculated that what should be the exact amount of production. Why? If the more production is done, that means the more holding will be done. If more holding will be done, then this extra money they will pay for rent. This extra money will be charged to the customer for the payment of the house or to pay the holding cost. As a result, that we are paying extra money for a single product if they are producing more. We do not make any mistake, they are making mistake, and we are facing the cost. So that's why this is the important part to maintain from the cloud computing and the AI code to save ultimately the cost, that the price has to be reduced, because that is the main concern of the bullwhip effect. That bullwhip effect is coming from this side, the wrong information, and this way the things are going. So that's why this is the connected thing, and no extra holding should be done. Now, if there are something like this, some extra holding is really needed, then how much extra holding, that could also be calculated through the AI. It is not like that, okay, huge amount of extra holding. So as minimum as possible holding is needed, so that part will be decided by the AI and through the cloud system. It is really not that task for the human being. So this way the connected system is going on in the smart production system. And for the smart production system, so what the main concern for my research, that suppose it is going on the multi-stage, like stage 1 to stage 2, stage 2 to stage R, stage N, like stage 1 product will be used in the stage 2, stage 2 product used to in the stage 3, and so on, like serial production continuously going on. So if this type of situations are going on, how we are maintaining the environmental issue, sustainability matters, and along with how do we maintain the reworking matters. So this is the framework. So we are going with the single stage first. So single stage, single cycle, then multi-stage, single cycle, then multi-stage, multi-cycle, then multi-stage, multi-cycle under the uncertainty. And the last part of the model is the uncertainty, where the problem needs to be solved. Which one we should go, or which one we should consider, the configuration. So that is the basic configuration of the model. The first model we are considering the uh, multi-stage single cycle and multi-cycle both. Then we are considering the reworking in the same cycle and reworking in the different cycle. And And then we are considering some discrete investment functions. That okay, can we consider some investment to reduce the cost or not? That we have done in the first model. We are extending this one with the totally consideration of the sustainability direction regarding the biofuel with the automated production. And the third one, whenever we are going for this one, then we have considered uncertainty to finalize the cost estimate. And this cost confirms that okay, exactly when the reworking must be done. So the first model is like this. That paper, please check that paper we published in 2019 that I have done alone, based on the concept of the multi-stage, multi-cycle. So that is the concept, and it's a large size paper, and that paper is the initiations of this area of research, what we have done. So let me explain about the framework that please check that the stage 1 to stage 2 to stage n we are defining, and then there are two sensitive things are there. That the first one is that the first fundamental law of manufacturing, and the Little's law as the second fundamental law of manufacturing have been used, and for each stage they have been used. And the most concern is that whenever the defective items are produced in the stage 1, should we consider for the stage 2, that means the this stage defective product, should we consider the carryover to stage 2, or should we consider the reworking within the same stage 1 again? So for this model, we consider two models here in the first part. So then we consider reworking in the same cycle rather than carry over the product in the second cycle. So that this way the modeling is done. These are the basic part of the contribution that the multi-stage, multi-production it has been done with to because it is very much difficult to control waste and all those things. And rework immediately it has been done in the same stage. It is not covered in the next stage. And if we are going for the because it's a smart production and the huge cost is utilized for the cloud matter and the artificial intelligence matter also, so then it is the most important part that setup must automatically integrated. That how do you reduce the setup fee? Now there are two options. One is that the investment in the continuous and investment is discrete. And do we need really continuous investment for always, or we just have a discrete investment? That is the thing. So we check that both the things are important. So it is the concern regarding the product, which product we are considering. If we consider some specific products, so then the continuous investments are needed, and some products are there where the discrete investments are needed. We consider some such products, some such that the discrete investments are more suitable for that one. So that's why we consider the discrete investment here. And optimization, we just use the classical optimization to get the conclusion. Now, this is the basic assumptions that, as you know, that if we have the imperfect production rate, then the rate of the rate of change of inventory must be say 1 minus alpha into P minus Q. So that way of that style that we consider the equation, and we are considering the defective rate whatever it is producing here. This is the random. And random means that anything can happen with any type of distribution, or it may not have any distribution. Both are possible. But again, the same point is that what the data we have, we check that it follows some distribution, it is continuous distribution, and the another point is that we check that this part follows something uniform distribution. Means that for the long time, if we check the data, so it is coming that uniform distribution is following. So what we have done, we are going with the uniform distribution, triangular, double triangular, beta, and then go for a comparative study. Okay, let's see which one is the best. But frankly taking, sir, what the data we have from the industry, that follows exactly the uniform distribution, so we do not have to go with the other distribution. But it's a matter of the research for comparative study that see other what will happen. Go with this one. But the data confirms is the specifically uniform distribution. And another thing is that two stage integrations are there. We introduce one thing. We introduce that specifically it is introduced by the Toyota company from Japan. The word is automation rather than automation. Automation is that it's a contribution totally by control by the machine, And automation in that, this is the same, but it will be covered with the supervisor. So some simple supervisor will be there, and he will confirm that the task of the machine is done. So that supervisor must be a skill level, otherwise he cannot understand what the things are going. So that way we are introducing automation within the system. So two-stage inspection process has been done here, and that we say the repeat investment we are using in this function. So this is the first model, reworking in the same cycle, and then the second model will be reworking in the different cycle. So I'm not going with the basic cost because those all paper published, anyone can take from the published papers. So this cost we are considering, that the setup cost, total cost, inspection cost. As I said, that two-stage inspection. So there is some info at that time, but now paper published, anyone can read that one and you can check that one, whatever the things are there. Then the holding cost, so then the reworking cost, then the inventory holding cost for the rework product because defective items are there. And then finally we can get the manufacturer total cost based on this all things. The point is that whenever we are going for all this matter of the cost, so this sorry, this is the part, that we are trying to go for the optimization, and there we are deciding that the reworking thing should be considered in the same cycle or different cycle. So this is the first stage, and go for the second stage model, that the same thing is there. That is the reworking of the last cycle. That means if we check the whatever the product, that means the defective items are produced, so it is moving in the stage 2, then stage 2 to stage 3, stage 3 to stage 4. So every time some part is added. Why? Because the stage 1 suppose 100 grams defective item. So then 200 grams. So 100 plus 200, 200 plus 300. So this way, the all defective items move to the end stage and then going for the uh, reworking for the last stage. So this is the second stage. So these all are almost similar. So there is something, the star marking in that part, the expected penalty cost for disposal of the defective item must be the different from the first cycle, along with the holding of the imperfect items and the finished product. So that should be the different thing from the first model. Similarly, the investment to reduce the setup cost also will be changed. So this is the part of the expected total cost from the first model with the uh, some constraints, which is the equality constraint. So you can, and this equality constraint is concerned about the investment function. Now you can ask me, okay, why do you use the investment for the equality? It can be the less than equal to type also, but there is a restriction that whatever bit of money you have to use within the cycle. The next cycle or next stage will have some different types of money. So that's why it has to be utilized totally. You cannot utilize for this one for the other side. So that's why in this way, investment is the equality constraint. No, as you know that this is a very commonly tested optimization function if we can use Lagrange optimization, so you can solve. So this way you can solve and get the global optimum solution using Hessian. We got that one also. So these are the results from going for the numerical. So whenever we are going for the numerical, we took the data from Professor SARKAR. Then he is in Louisiana State University, as I know. Right now he retired or not, I don't know, but uh, he has a paper exactly in the similar direction. So from there we collected the data, and then based on that I go for the numerical, and then this way I get the result. So the example 1, 2, 3, 4 are designed like four different types of institutions and different types of results. But frankly speaking, we may consider the first example much more because that is the data indicate, and the rest we say that okay, let's keep the data, consider the terminal distribution, what will happen. So this way you can get the result, but example one is the best one because of the data matter. And that is the result, that the total cost, optimum total cost distribution, optimum order quantity, and these are the investment. Next, this is for the second case, if the reworking in the last cycle. So then from the second cycle, triangular distribution gives the best result. And then if we go for some numerical experiments. So then this way the results are coming. So you can see from the graph. This is the some concavity weakness that they are optimizing, keeping that matter. So finally, what we conclude that the discrete setup cost reduction is really reduce the budget matter, and we are having this confirmation that when the rework will be done, the rework definitely will be done in the last stage. And for each stage, we are considering that stage one for model one and the model two. So then for each one, we can consider the reworking within the same cycle for two different types of distribution. One came from the double triangular for the second one, and for the first model came from the uniform distribution. So as we said that the based on the uh, data that the model it shows the uniform distribution, so then you can complete the rework within the same cycle. But if the defective item pattern change, so then the result is changed. That's why we want to show during changing this data that the result is coming different or something. Go for the next model. Okay, the for the future extension, we are going with the smart production system, and we are going with some more complex system with some sustainability dimension. So then this is the model 2, that the smart multi-stage single cycle production. We did not go with the multi-cycle immediately because we need that one for biofuel production, and we go for biofuel production immediately. So then if you check in the title that the sustainable biofuel production is there, and that basically we have done in 2020 when you see the paper publication. So this is the similar, but what the main concern for the biofuel matter that in between the several steps it has been changed because general production like a paint production and the biofuel production is totally different thing. So that's why we have to follow their style. Their style means the biofuel production style rather than the general production style. So that is why this production flowchart has been changed. These are the constraints, so notation, and these are the basic assumptions similar like the last one. And there is a big deal that let me tell you the deal matter that the track matter that there is a concept of the track that two types of tracks are available. One track is the 16 wheel track, and the second type of track is the 20 wheels of track. The point is that in the 16 wheel track, the cars are the track is small size, not so small. It is compared to the 20 wheels, it is small, but the emission, carbon emission is less. Also, the uh, ton per ton, the price is also less. Similarly, for the 20 wheels track, the carbon emission is also more, and the that one means that per ton, the amount is also much more. So this type of things we have considered for the transportation matter. That means the uh, heterogeneous logistics rather than the homogeneous track and also. So these are the both exactly like similar, but there are some changes. Like a raw material cost, there are so many things are considered. Just which just exist in the earlier case because of the biomaterial biofuel raw material distribution. And this is the production matter of the biofuel, which is again the different changes like the earlier one, but almost similar. Similar you can say, but not same. So this way we are going with the carbon emissions, another different way of formation because that carbon emission and this carbon emission is also totally different because biofuel, you know that it is a green type of product, so it will produce very less amount of carbon emission. So that's why earlier biofuel, sorry, this carbon emission and this bio emission has some controlled way of emissions are being used. Then Then the transportation cost and the bio transportation cost I explained already, similar for the emission. And these are the holding costs for perfect biofuel, imperfect biofuel. This is the imperfect biofuel is nothing but impurity in biofuel. Okay, so that part is we have considered also. And this is the total cost. We got the optimum solution, exactly the similar way of the classical optimization. These are the results. And we got the similar way first case the example one, that uniform distribution, and if we check the cost, it's a huge amount increase, but do not worry about that one. That if the cost increase, then why do you consider this model? Because this is totally the product change. Even though it's a similar type of concept, but the product change, so cost and all these things have been changed. And we are comparing with the two historical cases with the constant production and the constant production and no investment. Then whatever changes are there, we ignore this one. These are the numerical experiments, skipping that part. And finally, we are concluding that if the cost has increased so much, so we must have to do something more. Then for that case, we are trying to consider, let's go for it with the uncertainty. That if we go ahead with the uncertainty in the fuzzy system, let's see that we can reduce the cost of it. So then, the third model we are considering third multi-stage single cycle production system with the uncertainty matter. So we are defining like two ways: reworking in the same cycle, reworking in the last cycle. As it is on the first type of model, but uncertainty is there. And then that paper will publish with one of my masters. Now he is PhD, but that time he was the master student, completed with his graduation with that paper. So we published that paper in the latest slide, and this paper published this year. Even we submit so much earlier, but it takes so much time. So this paper published this year, and there we have used the fuzzy system. So what we are trying to do this thing in the fuzzy sense, the cost matter specifically. The similar dimensions we are going on as on the earlier. So you just take it at the uncertain environment in the form of positive one and follow the triangular membership function. We take the data from some other paper covering by triangular distribution. So you can say why triangular it should be the trapezoid. There are so many things out there. Why you don't consider that one, or type one fuzzy or type two fuzzy. But we are just going ahead specifically with the data pattern and the based on the data what exactly is coming. We are just going ahead. We just want to verify that which one is working for us in the reality case. And then we are going with the fuzzy cost also, that, and using the scientific method, you go for the reduction of the reduction of the cost for the representations for scientists, and then go for the reduction of the cost. And we are going with the similar type of investment function as on model one. And these are the basic costs. Okay. So there are the changes that whenever we are considering the production cost already we consider earlier, and then this cost we are changing to the fuzzy production, fuzzy setup, because you know already I said that setup cost increased so much and we are trying to invest so much to reduce the setup cost. So we go for the uncertainty so that this cost can be reduced. So then go for the fuzzy processing also, fuzzy inspection also. So all cost we are transferring to the fuzzy so that it can be reduced more. And then that you know that the membership function, I am not going to explain membership function again based on the triangular fuzzy numbers. And this is the explained this way that the uh, due to this creep matter and the fuzzy demand matter and the matter of the fuzzy cost, what the extension has been done. This is the original one earlier, whatever we have. And then this is the last part, which is the additional formulations are there because of the change. So we just separate it for each one, that what is the extra part is added on now. So then based on the classical optimization, we got again the result. The same thing here we have used and got the results also. And the same data we have used as on my paper. And based on that, we are getting the result. So we just checking that for the case one, that whenever the fuzzy we are using, even though it is not reduced so much, but still it is reduced, and we just have the, we cannot check with the other, like earlier cases we can check for other distributions. Here we really cannot check with the other fuzzy number because of the data, because the data available from that one only. So that's why we only strict for the triangular fuzzy numbers, and that's why we just check with this TFS method. So that is the result comparative study for that one. It reduces the cost, which we really want. And similarly, we got the sensitiveness with parameters are more sensitive, similar like the earlier cases. And whenever we are checking this one, that we please check for the model one, it reduces near about 12.9% of the cost, which is really is not a small amount because the big amount of money is going on. So this money reduction is huge. Similarly, whenever we are go for model B, I'm just going for similar type of thing. So it's just like a one single kind of product we are considering, and then the similar type of cost. So only considering is that the last part is the reworking will be done with the part of the fuzzy. So fuzzy production, fuzzy setup, fuzzy inspection, and all those things. Inspection and all. Okay. And the same thing as I said that except TFN we cannot use, so we are going with the TFN again and go for TFN generation functions and cost also. So we separated this way. The first part is covering by the original one, and which part is considered extra part for the fuzziness that we have done in the next part. So this way we have done, and for both cases, and then go for the optimization with the same class structure, and you go for the result using the data. So then you please check the data result is coming from the first one, that 257, the first case is coming something more or something less. So that is the another concern, that should we go then for second part or the first part. But as we know that the result is coming from the first part means that the defective reworking must be in the same cycle. So then we can conclude this way that effective is going on in the same cycle, then the cost is reduced, that is also sustainable, and the production task is also done, whatever we needed that. So this is the whole sensitivity matter for the most sensitive elements and less. So here the cost reduction is like this way. The one which second only first scenario the cost reduction is done, but that is 11.6%. But second one increase. Finally, we can conclude that the cost reduction, if we are going with the 12.9% in the same cycle, if the reworking has been done, even though fuzzy is there. And if it is the difference, so then it will be 11.6. So then what is exactly the conclusions are going on, that if the reworking we have to do, then it has to be done in the first cycle, even though it's a single stage, even though it's a multi-stage, even though it's a single cycle, even though it is a multi-cycle. And this way we check with the crisp and the fuzzy both ways, and finally concluded that the reworking must be completed within the uh, same cycle so that the cost will be reduced. And the future extension, the major part, we have another paper in progress that is in 2022, but that is in that we have done the multi-type paper, but there we did not consider this all multi-stage, multi-cycle, because it becomes so much complicated. Now my task is that working with one my student, that this already we have put. Now we are going with combination of these two studies, that multi-type, because I said pen is pen. The second one only biofuel, the single type of product. So now I'm considering multi-type, multi-stage, multi-cycle product. So going with each one with the more reality, and with covering by the different types of products. So this is the future extension task, what exactly I wrote, and I'm doing that one. And there, the another thing we are considering the system reliability. That I started the combination of the system reliability and inventory modeling in 2012 and 2011, when I was exactly in the Bindajal University. So after that, I stopped that research. So this research I started again, and I have published two papers recently, combination of the inventory and reliability. So this inventory reliability I'm trying to incorporate here also. So it will be like a reliable, smart multi-site. So this way we are going with the future extension of the modeling. That I'm planning for that one. And that is the research what exactly I would like to present for today. So thank you very much. So this is for references. Thank you, and that's my mail ID, phone number. So if you have anything, if you have question or anything, you can send me by mail, phone, anytime. Thank you very much.
So, thank you, Vishwajit, for your excellent and informative presentation. So now I request Professor with Dubey to continue the next part, the chairperson of this session. Mr. Dubey.
Yeah, thank you, Dr. Bishwajit. Thank you, Dr. Madhumanipal. And nice to talk to you, Professor Sarkar, after some time.
Thank
I
you,
just
sir.
had one small question.
Please, sir.
So this, when we have inspection stages,
Mm,
so my question is there a way
mm,
to think about machines
yes.
correcting? So instead of, can we assume that the rate of rejection
Mm,
can be statistically controlled, so we
mm,
really don't have
mm.
much as a form of defects?
Yes,
Is
sir.
there a way
Possible.
to,
Possible,
so
sir.
yeah. So because I understand statistical process control, so that's my question, and I will be interested in thinking in that line and modeling something if you are interested.
Definitely, sir. If I gave you my phone number, email ID, and all
Yeah,
the
yeah,
things,
yeah.
anything you need, you just talk anytime.
So I was
Or
hoping that that approach might reduce the inspection cost, but the question will still be, what is the cost of the statistically controlling this whole thing,
no, sir. It
right?
is very less cost because it was introduced more than 100 years, 100,
Yeah,
150 years before by the Toyota company, and the process
right.
name is the automation. That they started with something placard type system. Like said, that times
Yeah,
of phone call or this type of internet things are not available. What they are doing, stage one, some people that is who is the labor. So whenever the task done, he just raise the hand with a placard, and then
correct.
if he shows placard, that means his stage one task done, first fundamental task done. So then stage two, serial production, stage two, then he started to work. Then when the stage two is done, he shows the placard. So this way the placard systems are going on that time. That
Yeah,
things is the no named as the automation. And now these things are coming with the automated system, not this placard system. So the
correct.
cost is very less.
Right. So the machine itself can tell
Itself
you
can
if it is
define.
under control.
Totally,
Then
sir.
the machine will tell you if it is under control, and then we don't
Yes.
need to do inspection. So anyway, that was one way. Question is, how much will it cost? It's not a separate cost as far as I am concerned, because it's a part of processing, and as long as the input of where statistically the trend is, if that is read properly, then we don't have an issue. There may still be some rejects, I don't know, but
Yes, sir. The point is that I mentioned during the presentation that
yeah,
there is a point that whenever this process will be done, only one supervisor is there, and that
right,
supervisor must be the skilled labor. Semi-skilled or
right,
unskilled labor never be used for this purpose. That's
yeah,
one. The role
I
should be
totally
same
agree. I
for.
noted that. Yeah,
So
agreed.
that's the point.
Okay, yeah, thank you so much.
Thank you, sir.
And any other question from audience?
After a long time, I see the room, sir. Background.
Yes. Any question? So there is no question. So thank you, Professor Vishwajit Sarkar once again. And from our society, Ms. Siddhar Acharya Academy of Mathematical Sciences, it's pleasure and honored to present an outstanding researcher award. So I am showing the certificate to Professor Sarkar and will send shortly through email.
Okay. Thank you, sir.
1 minute, 1 minute. I am showing your certificate. Have you seen?
Yes, sir. Let me read little bit.
Uh,
Thank
this
you, sir.
certificate provided.
Thank you very much.
Thank
Thank you, sir.
So, the